Pythagorean theorem and its converse. Pythagorean theorem. If a triangle is a right triangle, then a squared plus b squared equals c squared. This is Pythagorean theorem. So this is side A, B, and then this is hypotenuse. So leg, hypotenuse is across from 90 degrees. So that will be c squared. So A, B are always the leg, the straight sides, and then C is always hypotenuse, the longest side. Converse, if a squared plus b squared equals c squared, then the triangle is a right triangle. So the converse is telling you that if a squared plus b squared equals c squared, then the triangle is always right triangle, which is what the Pythagorean theorem is all about. So solve for the missing side. We have A is 21, B is 20, and what is C? So we're going to do 21 squared plus 20 squared equals C squared. So we're going to calculate 21 squared, which is 144, 20 squared, which is 400, add them together, which is 841, do square root of that. That will give us length for C. So C is 29. So if you have squared, opposite of square is square root. So if you do square root, that's going to give us the length for C. If A is 8, B we don't know, C is 20, find B. 8 squared is 64, we don't know B, so that's B squared, equals 400. 20 squared is 400. We're going to subtract 64 from 400, which is 336. We're going to use radicals to simplify. So we're going to do the factor tree. So the answer is 4 radical 21. So please write your answer in radicals form. So I don't want decimals, okay? Don't want decimals. We're going to find A. So A squared plus 26 squared equals 36 squared. 26 squared is 676. 36 squared is 1296. We're going to subtract 676 from 1296, which is 620. We're going to do the factor tree. We're going to do square root this, and you should get 2 radical 155. The next one is we're going to do a squared plus b squared equals c squared. The difference is this is you have a radical here, 3 radical 2, 5 radical 3. So if you do 3 radical 2 square, it's going to be 18. And you can actually put this in the calculator with the parentheses, and then it's going to give you 18. The reason also is 18 is 3 times 3 is 9. Radical 2 times radical 2 is 2. When you multiply same radical each other, that is regular number. So 9 times 2 is 18. Same thing for this. 5 times 5 is 25. Radical 3 times radical 3 is just 3. So 25 times 3 is 75. So if you put this with the parentheses in the calculator and square it, you should get 18. Put parentheses, put in the calculator with the square, you get 75. Add these two, that will be 95. So square root of C is 95. So it's a square root of 95. 93, I mean not 95, 93. You cannot simplify this, the 93. So please just leave it like that. So you notice that all the answers are whole numbers or in radical form. So you have to do the factor tree. So when you do the factor tree, the leftovers you multiply to each other, put it inside the radical. The pairs, they go outside. You also multiply to each other. They go outside of the radical sign. So Pythagorean triples, 3 positive integers a, b, c that satisfy the Pythagorean theorem. If ABC is a Pythagorean triple, then so is Ka, Kb, Kc for any positive integer k. So what does this mean? Common Pythagorean triple is 3, 4, 6, 5, 12, 13, 8, 15, 17, 7, 24, and 25. Can you put a star on 3, 4, 5, 5, 12, 13, and 7, 24, 25. So if you do, the longest side is C. So 5 is C. So A squared plus B squared will be C squared. So 3 squared, which is 9, plus 4 squared, which is 16. That's going to equal 25, which is C is 5. So this is 3, 4, 5. That is the common Pythagorean triple, 3 numbers. And then 5, 12, 13 is another one. C, this 13 is C. And then 7, 24, and 25, that's another common one, which is this is C. And 8, 15, and 17, that's 17 is C. But you usually see these 3. Those are the most common Pythagorean theorem triples. So those are the length for our ABC. Now, this only works for right triangles only. So the converse for Pythagorean theorem is A squared. If A squared plus B squared equals C squared, then the triangle is a right triangle. That is the converse for Pythagorean theorem. So these are the really common triples. So ABC, 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 ABC. Okay. So identifying the type of triangle, you can actually use Pythagorean theorem to identify whether you have a right, acute, or obtuse triangle. So when you have a right triangle, it is A squared plus B squared equals C squared. Hypotenuse is just right. But if you do A squared plus B squared, and if it's greater than C squared, then hypotenuse is too small. Then if this is smaller than when you add these two, because you square each one and you add these two, if it's smaller than that, if this is small, then that's acute. So that's going to be an acute triangle. And then, if it's when you do A squared plus B squared, and if it's C squared is greater, the obtuse is too big. This is too big, that's obtuse. So if this part is too big, that's obtuse. So when you solve it, and you get just right, they're equal to each other, that's the right triangle. If this part is smaller than these two when you add them, that's acute. This part is larger than when you add these two, that's obtuse. So that's how you know, by using the Pythagorean theorem, whether it's a right triangle, acute, or obtuse. So this is the only right one when you get equal. If you get small, that's acute. Small means acute. If you get bigger, that means obtuse, too big. So identify what type of triangle is made with sides. So let's try it. We have 4, 5, 6. 4 squared plus 5 squared. Does that equal 36? Is it bigger? Is it smaller? Right? So if I do 4 squared plus 5 squared, when I add these two, I get 41. 41 is greater than 36. So 36 is small. That's acute. Acute is cute, small, cute, acute. So this is an acute triangle. So by using Pythagorean theorem, you know whether it's acute, obtuse, or right. Look at this one. If I do, the longest side is C, okay? So this is C. The other two don't matter, right? So 16 plus 36 is 52. Because you do 4 squared, 6 squared, that's 16 plus 36, 52. A squared, 64. So 52 is smaller than 64. This part is, the hypotenuse is bigger. So that's obtuse. Obtuse means big, right? Obtuse. So you know that this triangle is acute, this triangle is obtuse. Take a look at this one. 10 squared plus 15 squared is 20 squared. Okay. 10 squared is 100. 15 squared is 225. When I add these two, it's 325. Is that smaller than 400? Yes. So this part, the hypotenuse is bigger. So that's obtuse. 2 squared plus 5 squared equals 6 squared. Let's try that. 2 squared is 4. 5 squared is 25. So that's 29. And this is 6 squared, which is 36. This is bigger than this. That's obtuse. Okay, that's obtuse. Because this is bigger. So if this part is bigger, that's obtuse. If this part is bigger, that's obtuse. If this part is smaller, that's acute. Okay, so that's, by using Pythagorean theorem, you can tell if you have 3 side measurement, you can determine whether it's right, obtuse, or acute. So I want you to pause the video and do the next slide and then check with the answer. Do the next page and pause the video and do the next page with the calculator. Tell me whether it's acute, obtuse, or right angle. So do this page, pause the video, please, and then after you write down whether it's obtuse, acute, or right, you're gonna check it. Pause the video and try. Please use a squared plus b squared equals c squared. The longest side is c squared, okay? C, which is hypotenuse. Pause the video. Here are the answers. Please check your answers. If you have a triangle with the side lengths 3x, x plus 1, and 3x plus 1, what values of x will make this a right triangle? So we're going to draw a right triangle. We're going to write 3x and then x plus 1 on the leg and leg. 3x plus 1 is going to be the hypotenuse, okay? Hypotenuse always away across from 90. It's the longest side. So we're going to do 3x parentheses squared plus x plus 1 parentheses square equals 3x plus 1 parentheses square. Make sure you put parentheses around each expression. A squared plus b squared equals c squared. So 3x times 3x is 9x squared. Make sure you write 9x squared. When you do x plus 1 times x plus 1, that's x squared plus 2x plus 1. You're going to use a box method or FOIL method and multiply. And then 3x plus 1 times 3x plus 1 is 9x squared plus 6x plus 1. Now we're going to combine like terms. 9x squared plus x squared is 10x squared. 2x plus 1. 9x squared plus 6x plus 1. We're going to move this to the other side. So 10x squared minus 9x squared is x squared. 2x, you're going to bring that to the other side. That's negative 4x. And then bring this to the other side. That is going to be that's going to be 0. So this x squared plus 4x equals 0. Then their GCF is x. So x parentheses, I'm going to factor this. X is out because they both have x. And then parentheses x minus 4. And then we're going to split this. So x equals 0 and then x equals 4. So x, we're going to use 4 for the, we're not going to use 0 for the measurement. So 4 is the answer for x. So I did the work here. You can actually look here. X squared minus 4x equals 0. So you can actually do the completing the squares and you also get 4. So this is also completing the squares. So you add the 4, you get x minus 2 squared. And then you're going to put 4 here, add 4 here, square root, then x minus 2 equals positive negative 2, add 2, you get positive 4. So if you do the completing the squares, you get 4 also. So the answer is 4. So please pause the video and copy notes and write the answer 4. Real life example, a fireman is trying to save a cat from a tree. The ladder he is standing on is 24 feet long and is 15 feet from the base of the tree. How tall is the tree? So please always draw if you have this kind of problem. So we don't know how tall the tree is, but the ladder is 24 and the bottom base is 15 from the tree. This is 90 degrees. So we're looking for leg. So x squared, this is what the tree is, plus 15x equals 24 squared. So 15 squared equals 24 squared. 15 squared is 225. 24 squared is 576. Subtract, which is 351, and then square root that. Simplify, you get 3 and square root of 39. So I don't want decimal answers. I want all answers to be radicals, okay? So please copy this and draw this picture. We're just looking for the height of the tree, which is a leg, okay, for a right triangle.